Alright guys, this is maybe take 51 of me trying to make an intro, so we'll just keep it at that. And in today's video I'm going to show you how to create a React Native C++ Turbo module on Android. Alright, in the previous video I showed you how to do it on iOS, so if you haven't checked it out, I recommend you that you go and check it out, because in that video we set up like most of the stuff, especially like the C++ library, the class, the implementation, everything. In this video we're just going to wire up Android and just make it work, so it really won't include like most of the stuff that we added in the previous video, which is most of the C++ code. So yeah, if you want to follow along, I have a repo called React Native CPP Turbo on my GitHub, which is called Isramiel. So I'll leave it in the description. So that's where I'll be working from. So actually I'll be cloning it and starting with you. So let's go ahead and clone the repo and cd to the directory. And next, just run yarn to install the dependencies. Oh, first, let's switch to feat iOS, because that's get switch cd. Wow. Feat iOS, because that's where we left off last week, or like last video, and that's where we want to continue from. So now we run yarn and then install the dependencies. Alright guys, now that the dependencies are installed, let's go ahead and check out our directory or our repo, right? So basically what we have here is a React Native module with an Android, CPP, iOS, and source directory, each respectively like for the platform, right? For Android, iOS, and source for JS. And there's an example directory which just have a React Native app which allows us to test our module. Now we'll do most of our work in the Android directory. So let's go ahead and expand that. Now, technically, guys, we really don't need anything other than this file, cmakelist.txt, all right? And I believe that's how it's going to be in the future. But for now, all right, we need to keep a couple of stuff. So, but the cpp adapter.cpp, we do not need it. Now, when this module was created for us, we used create React Native library, if you checked out the previous video, and we chose Turbo module and C++. Now, even though we chose a Turbo module in C++, it doesn't really create a pure C++ Turbo module, right? It still uses like kind of an older approach where you invoke a method which invokes a method in Java, or Kotlin which invokes a method in CPP. However, we want to go direct JS to CPP, so we need to edit the stuff here. So CPP adapted, as I said, in the future we don't need any of these files most likely, but for now we need some of them. But the adapter, we don't need it, so go ahead and delete. Inside the source main, the manifest we do not need, so just delete. Inside Java com cpp turbo, we do not need the module, but we need the package. We actually do not need the package, but we need it for React Native to work, but we're going to empty the implementation that's inside it actually. So now that we deleted this stuff, in order to edit the CPP Turbo package, to kind of empty it out or just remove most of the stuff, I prefer to use Android Studio whenever I'm like working on an Android project. So let's go ahead and open Android Studio, and then click on Open, and then I have it on my desktop. CPP, yeah. Now don't open the Android directory, which is directly under the React Native CPP Turbo. Go into the example and then open the Android, right? So you want to open the Android project of the example project, which has the module linked in it. So you'll be able to see the module inside it, and also edit the module, which edits the module directly. So go ahead and open it. Now, Android Studio takes some time to kind of initialize, so we'll wait for that. Now that Android Studio did its thing and it's working now, as you can see, this is our app, which is our actual example app, and this is our module. So you can, as I said, you can see our module inside the example app. Now in here, Java is where we see our CPP Turbo package, and here we should be able to see our CPP code, but it's not working now. We're going to make it work, and by CPP code I mean the CPP class that we did in the previous video, which is this one, right? The header and the implementation file. Anyways, guys, so let's go ahead and edit this package. Now, as I said, we do not need it really, but we need it. So we're going to just remove, like, React Native need this file in order to kind of properly generate the code, like code gen. However, the implementation inside it really can be nothing. So for get module, we're not really going to return a module. We're going to return null. And for this other method, it says get React module info provider. So basically, we need to return a map which with the keys of the module name and the module info. However, as I said, we're not returning anything. So let's go ahead and return a collections empty map, right? Like a reference to the empty map, basically. And we need to return that. And good, guys, that's it, really. Nothing too much. Now, what's important, right? Now, most of the stuff now, we just deleted files, emptied files. Now, let's actually work on the thing that makes stuff work, which is cmakelist.txt. Now, if you're not really aware of cmakelist.txt, let me just briefly explain it to you. It's just a configuration file that creates a build system for C++ projects. So it allows you to kind of build C++ projects and do lots of other stuff for C++ projects. And we didn't really have to do this for iOS. Like if you watch the iOS video, we didn't really have to do that. And that's because in iOS, like in the iOS environment, it's kind of C++ is kind of natively integrated into it, kind of, or like it's very easy. You don't have to do anything yourself. It just works. However, in Android, in order to kind of bundle up C++ and build it into the app, you need to have a cmakelist.txt. And this is not really React Native specific. Like if you want just a pure Android project, right, and then add some CP code, you need to add a cmakelist.txt. So guys, let's go ahead and change this to make what we want work, right? So these two lines can stay. It's just setting the CMake minimum required version, that's fine, and naming the project, which is also fine. We can keep the CMake variables file on. However, the C++ standard, we do not want it to be 14. Let's delete that. Now we need to add a couple of compiler options, I believe. Let's go ahead and check my snippet. Yep. So we need to add some compile options. So we are setting the C++ standards to 17. And here this one enables runtime type identification. And I mean, that's what this add compile options is specified in the React Native documentation. So I'm just adding it. Probably it used this internally, I'm not really sure. And as I read, this enables exception handling in C++. Like, I'm not really sure why you need to enable it. I thought it's by default you can capture exceptions or like handle exceptions. I even tried to remove it and it worked, but we're just going to keep it for the sake of being complete, and maybe my example doesn't trigger like a use case for this one. So I'm just going to keep it just in case, you know. Next, this add library. Now we're going to edit this one. In here, you just add the name of the library and the C++ files that are needed for this library. And if you recall, we deleted the cpp adapter.cpp, so we can remove that. And when the project was, like the module was generated for us in the previous video, there was a file called React Native cpp turbo.cpp. However, we changed that with this file, right? So let's go ahead and use this one, the one that we want. And also, it's no longer shared, it's going to be static, okay? And that's because in the previous implementation, or like the old implementation, you would load the library inside the Java class, and for that you need it to be shared. However, as I said, we're not going to have like the JavaScript called like Java and Java called CP. It's going to be direct between JS and CP, so it can be static. We're not loading the library at runtime. And yeah, next we're going to remove this include directory, and we are going to add, yep, target include directories, yep, public, and yep, cpp. Thank you, SuperMavin, for helping me. I think it's called SuperMavin. I added it recently and sometimes it's helpful. Anyway, so what we're doing here is basically for a given target, we are specifying the include directories. And what are include directories are just a directory which includes header files, right? So for example, let's say we want the header file for this code, like we are using it somewhere. we want the .h file. We are telling the build system to look for it in the CPP directory, right? So inside the CPP, there's this header file, right? So that's all we are doing here. Finally, we need to link our library with a couple of other libraries. And again, thank you, Supermaven. Target link libraries. We want to link our library with, so not Android, we want to link it with JSI, with React underscore native module core, yeah, and React underscore code gen underscore rn cpp turbo spec and close. So these two are kind of constant, I believe. You don't have to change these. However, this third one depends on your module. And this is React, not Rect. React. Code generate turbo spec. Yeah. So this part is constant, right, until the second underscore. However, this part depends on your module. And to be able to know what this part is named for you, you'd have to go to the package.json of the module, package.json. And at the end, there's a codegen config here, and then there's a name. And the name here, it's rncpp turbo spec, and that's why it's rncpp turbo spec. Now, this codegen config was created for us because when I generated the library in the create React Native library, I chose turbo module. And when you choose a turbo module, you have a codegen config. So yeah, now that we did that, I believe what we can do now, yeah, we need to do one more thing. And that is to add a React native.config.js, right? Now, if you're not aware of React native.config.js, it's just a configuration file that has some options that you can edit. And these are like predefined options, not like anything arbitrary that you can add. All right. And one of these options are what enables auto-linking of C++ turbo modules on Android. Now, if you're not aware of auto-linking, historically, in the past, in React Native, it used that when you used to install a React Native library, you'd have to manually link it. And that's like you'd have to go to your build.gradle or whatever and add in some stuff. But if you're new to React Native, you're probably not aware of this because there's something called auto-linking, and that's where you just do yarn add whatever, and it just works fine. And in order to make it yarn add and just works fine for CPP turbo module, we need to add this part. And let me show you what we're going to add. Snippets, and yeah. So as I said, this is like a predefined structure that's kind of defined in the React Native. I think it's in the React Native CLI, but anyways, so there's dependency.platforms.android. There are those three properties that you need to add. And the first one is the name of the CMake lists module name, like C++ module CMake lists module name. And basically that is just the, let's go to Android, CMake list.txt, and you see this one, add library. It's just the name of the library of this one. So it's React Native CPP Turbo. We added here React Native CPP Turbo. And the second one is the C++ module CMake lists path. So it's the path to the CMake lists.txt. And usually this is relative to the, not really, usually, by default, you can change that, but by default, it's the relative to the Android directory. So again, this is the Android directory, and the CMake list.txt is just directly at the root of the Android directory, so we can just add it as it is, right? There's no need to add anything else. If it was inside another directory, like then you can, then you could be like, something, you know, and then CMake list.txt, but for us, it's at the root. Finally, we need to add the C++ module header name. It's just the name of the class that you implement your module in. And in my case, it's native CP turbo module. So I'll just add that here. Now that we did all of that, I believe we can just run the app, guys. So let's go ahead and try and test that. Now, let's go to the project. Now, just a heads up that this is going to fail. All right. Okay, we need to go to the example directory and it's going to fail. But it's because I want you to see the error and then we edit, like we make it work, all right? All right, guys, so it failed, which is good. So it's kind of hard to find errors here in the command line, but anyways, it says fatal error, react dash codegen forward slash rncp turbospec jsi.h file not found, and that's in this file, native cp turbo module.h. So if you remember, when we opened the Android Studio, and also now, you see there's no CPP directory, or like you can't really expand it. So if that's the case for you, now that we changed the cmakelist.txt, right, we changed this one, we are adding the reactnative.config.js. So what I want you to do is go to here to build and build the project again, right? Now that we added these stuff. And now the CPP directory, as you can see, now it understands all that there are CPP files, and that's all because of our cmakelist.txt, right? Because let me show you again. Here we are saying that this CP class is included and the headers are also in CP class, so now it knows to include these files. Anyways, let's get back to the error, which is this one. It says this one is not found, react forward slash codegen forward slash rncp whatever. Let's go to this class, and yep, as you can see, there's a squiggly line. It can't find that. And so if you haven't seen the previous video, again, this file is actually a generated file. We did not write this file, and this creates a generated C++ class, which we are inheriting from. Now, the thing is, our C++ module, which is these files, these are common for iOS and Android. However, the header file, like this one, the generated files, is different for Android and iOS. So that's how it was for iOS, and it works fine, but for Android it doesn't work. So it's going to be different, and in order to handle this like difference, we do it this way. Let me show you. Snippet 3. And yeah, so we say, so this is how it works for Android, all right? Like you just have the header file without a React codegen in the beginning, and you can include one or the other this way. So you say, if we can include this one, like if it's available, then usually it's iOS, and then we include it, and then else if we can include this one, then include it, which is usually Android. Now let's go ahead and try and build the app again. And now it should work unless I have a bug which I'm not aware of. All right, guys, so built successfully, and we are on the new architecture because it says Fabric True, and also in bridgeless mode. So just so that you're aware. Now let's go ahead and check reverse string. Yeah, works. So again, if you didn't watch the previous video, let's just quickly go to app.tsx. We have these 5 functions which we implemented, which are synchronous functions, except maybe for call me later and promise number. Actually, let me show you the spec, right? So these are the 5 functions. Reverse string is a function that takes in a string and reverses it. Get numbers is a function that returns an array, and get object is a function that returns an object, obviously all from C++, right? So this object is created in C++ and returned, and that's an array that's created in C++ and returned. Promise number, same, like these are all C++ functions, and I showed you how to create a promise a function that returns a promise, and callbacks. So back to the example project. Are we here? Yeah, so we have just a button for each function and just console logging each of them. And let's try get number, and returns an array, and get object and returns an object, promise and callback. And callbacks is just calls randomly one or the other, successful or failure callback. And it works, guys, so perfect. As you can see, synchronous functions, promises, callbacks all work, and it was pretty simple because we set up most of the code in the previous videos. Now, what I want you to kind of, as I mentioned in the previous video, I'd like to show a couple of improvements, right? So let's go ahead and check our CPP file. Let's go ahead and reload the project because it's showing me some errors here. Yeah, so no longer it's showing me errors. That's cool. So yeah, I would like to show you guys some improvements. Let's actually also open the header file. So this reverse string return like takes in a JSI string and returns a JSI string. However, wouldn't it be like much more interesting and cooler if we can just take in a standard C++ string and return a C++ string? Like we don't really have to be aware of JSI, right? That would be interesting because then any C++ developer could just write this code and it has it work. It doesn't need to be aware of JSI or like anything React Native. So let's give that a try, you know. Let's do std string str and then std and we return a std string. All right, now just keep in mind that the class that we are inheriting from, it defines the function as a JSI string return and a JSI string like input value, right? So let's go, so we change it in the header file. Let's go ahead and change it in the implementation file. So we say std string, and let's change that to be this one. And also here, std string. Now, not only is this like better because you are using standard C++ types, but it's also like easier because now we don't have to convert the JSI string to a C++ string. We can just delete that. We can directly use the C++ string, right? And finally, we don't have to return a JSI string from the C++ string. So we can just directly return the C++ string. So let's do that. So it would be really interesting to do that because we cut down code and we made our code less JSI. Like it's not custom, right? Anyone can write this code. So let's try and build the app really and see what happens. But bear in mind that the class that we're inheriting from mentions that it returns a JSI string and takes in a JSI string. So let's see. So it's successfully built, and let's go ahead and try reversing. And it works. Like we just use C++ types and it works. And that's because like turbo modules by default accept also C++ types, like standard types. So you can use C++ standard types instead of JSI. And this is something that was not available in the previous tutorial, not the previous video, but the 2 and 3 videos before when we created a JSI module because it was very manual. However, when we're using now CodeGen and C++ Turbo module, we can do that. And also, we don't have to, for example, here return a JSI string. You can do an std array, or even the problem with arrays is that you need to, not a problem, it's just how it's defined because it's probably more efficient if you know. So the thing is, with arrays, you need to define the size, right? So it's probably more efficient if you know what's the size of the array that you want. But it's even cooler that you can even use a vector, right? So you can do an std vector and say that I want to return a vector of int. And if you don't know what's an std vector in C++, it's just a dynamically sized array. So you can just add stuff in it and just return it, compared to the previous implementation of array where we had to say that we need a 10 element array. Like sometimes you don't know how many elements you're gonna have, right? So it's cool to be able to use, guys, how many, is anybody counting like how many times I'm saying cool? Because it's probably way too much. Anyways, just add an std vector. Let's go ahead and change that here and do std vector of int. And then we just do std vector int like our array. Yes. And then we say the way that you add stuff to arrays is you do pushback, and then we need to static cast the so this is of type, we need to put inside it like I, the index. However, I is of type size t. We're just casting it to an integer because we are returning a vector of integer, right? And then this should work. However, let's also do objects, because not only can you return a JSI object, but you can also return an std map, right? Which is a C++ standard map. And we say it needs to be a string, a keys of strings and values of string. So let's go ahead. Let me just copy this because it's a bit too long. I don't want to keep on writing it. In the CPP, we can remove this, put in this, and for this one, we can do this and like this, right? Yeah, I guess. Did I mess up something here? Yeah. So next, we can just use a standard a map as you would usually use it, and that's you do insert and then add in a pair of std pair, right? And then just say result and success, right? I mean, you can see like this is way easier than object.set property, and then you pass in the runtime, and then you pass in the key, and then you convert the success to a JSI string, create from if8, and return and pass it the runtime again. Right, just way simpler. So let's run the app once more, one final time, hopefully. And now that this is built, just keep in mind that we changed the JSI types to C++ standard types. And let's go ahead and test the get number and get object. And as you can see, guys, they work, which is pretty interesting because we're really not using custom stuff. And this should also work for iOS. I mean, you can run it for iOS, that's also fine, and it will work. So thank you guys very much for watching the video. If you thought that this was useful and you learned something new, please give it a like. This way I know that you enjoyed it. If it wasn't good or like anything that you didn't like, please leave it in the comments. And let me know like how can I improve, just provide feedback. And if you'd like to know when I post a new video, just hit the subscribe button. And thank you very much for watching, and peace out.